Hi guys, I'm Julia. My summative is on batteries. I'm doing 3 connections today. My partner Tim is doing 3 connections on the same topic on a different YouTube video. You can find that somewhere on the channel. So I'm going to talk about redox reactions, electrolysis, and the chemical composition of electrolytes today. The first and central main thing I'm going to mention is redox reactions. They're how batteries work, so they're very important that we understand that. They're electron transfer reactions, and they must happen together in order for there to be electron flow. They can happen by themselves, but when they do, they're called half reactions, and only half of the process would actually be completed. So in order for there to be complete circuitry, the reduction and oxidation reactions would have to happen simultaneously. So one end of the battery, one electrode, the electrons are produced, and the other end uses them up. This is oxidation and reduction. So oxidation, electrons are transferred, and reduction, they're accepted. The substance that loses electrons is called the reducing agent, and the substance that gains electrons is called the oxidizing agent. So they're flipped from their original name, so that can be a little confusing, but if you use it after a while, you get used to it. The reason this is so important is because they're the backbone to how batteries work. Without redox reactions, we wouldn't know why electricity was conducted. We'd be ignorant people thinking that electricity was unexplainable by science and some kind of God phenomenon, or if redox reactions didn't exist at all, and assuming there was no other evolutionary substitute for them, electricity would not flow in the first place, and we would not be so technologically advanced nowadays. So that's very central and important to chemistry and batteries, and my summative. The second thing I'm going to talk about is electrolysis. And we know that in a galvanic cell, such as this one, little normal battery, right here, energizer, the energy is stored in the battery, and we can recover this by reversing the charging process. Electrolysis is the battery going backwards, and the reaction is non-spontaneous, which means it requires energy, and that energy is supplied via an external battery or an external DC current source. It's the same setup as a galvanic cell, except that the anode and the cathode are flipped, and this causes electrons to flow backwards in the opposite direction. And we have to remember that the setup for a galvanic cell is 2 electrodes immersed in a liquid of some kind, and the liquid contains an electrolyte, which allows electricity to flow. And I will talk more about the importance of electrolytes in about a minute or so. We have to remember that electrolysis is the passage of a direct electrical current through something molten, meaning melted, or something that is dissolved into a suitable solvent in liquid form, resulting in chemical reactions at the electrodes and the separation of materials, and those materials are what we can use. So if we want to break up a metal into its ions, for example, the metal will be deposited on the cathode, and this property can be used in things such as electroplating. It can also be used with electrolysis of water. Yes, water gets in on this act too. So oxidation happens here as the liquid gives electrons to the anode, and reduction happens as at the cathode as the water is reduced to hydrogen gas. And we can use the hydrogen and the oxygen in manufacturing processes. The reason electrolysis is so important for our understanding is that because it is the reverse of batteries, if we understand electrolysis, we can essentially flip the anode and the cathode, flip the concept, and we now understand how batteries work. We know that in science, typically, if we understand things one way, we can reverse the concept and hopefully gain a deeper, better understanding of the same concept. So that's why electrolysis is so important. And the third and final thing I'm going to talk about is the chemical composition of electrolytes. So, as I just mentioned, in a galvanic cell setup, you have the electrodes and the liquid, which contains an electrolyte. What an electrolyte is something that allows electricity to be converted through it and allows electricity flow to occur. However, the liquid can't just be anything. For example, water won't conduct. Pure water anyway. Tap water will. I'll explain why. Pure water won't conduct because it has no ions in it. Tap water, however, is typically hard water that we get in our houses, has things like calcium and magnesium ions in them, and those ions will conduct electricity on their own, meaning that tap water will conduct slightly, and that's why people tell you not to plug in a toaster or some kind of other electrical appliance while taking a bath, because you will get an electrical shock. Tap water will conduct electricity. And we have to remember that there are lots of other really good electrolytes out there. One of the ones we use a lot in chemistry is sodium chloride, NaCl. So NaCl is an ionic compound, and it's held in a really rigid lattice formation, and it's held together mainly by the large amount of positive and negative attractions between the negative chloride and the positive sodium. Because it's such a rigid lattice structure, it has a very high melting point. However, when it is finally molten, or either that or in an aqueous solution, it dissociates almost completely into its ions, and those ions, because there are so many of them in solution, conduct a large amount of electricity. So if we put, let's say, table salt into distilled water, pure water, into a liquid for an electrolyte, the water will now conduct electricity. And this is very important to battery setup because electricity must flow. So if we have something like sodium chloride in the liquid, the ions will conduct the electricity, and it will be able to go in one electrode and out the other, and it'll be a continuous electrical circuit. So those are my 3 connections. I hope you enjoyed them, and I hope they made sense. And thank you for watching.